Hi everyone. So here we have distance versus time graph given. I prepared some things beforehand so we don't spend too much time drawing these things. So we have given a distance versus time graph here, distance in meters and time is in seconds. So we have a constant velocity motion in the first region and stationary in the second region, and again constant velocity in the third region with a different velocity. So here my aim is to show you how to find slope for these three different regions of this motion. And while doing that, I'll show you how to draw velocity versus time graph that we can deduce from this distance versus time graph. So I named this 0 to 10 seconds region as number 1, 10 to 35 second is number 2, and 35 to 55 second is number 3. So for the first part, the slope 1 is the region 1, basically, is going to be found by using origin as the first point. So if you remember, slope is y2 minus y1 divided by x2 minus x1, basically rise over run, or delta y over delta x. So in this case, the second point that basically is where the number 1 is ending is 10, 40. So the x is 10, y is 40. And it starts from origin, so it's 0, 0. Therefore, when you try to calculate slope for the region 1, what you do is that y2 here is 40 minus y1 is the original point, which is origin, so it's 0, divided by x2 is 10. And x1 is 0 again, because the motion starts at the origin. So you have 40 divided by 10, which is 4. And the unit is meter per second because y's are given in meters and x's are given in seconds, right? So it's going to be meter divided by second. And this is positive 4, which is important because it's, as you know, velocity is a vector, so you have to define its direction. So if you want to give the velocity of this motion in the first region, it is 4 meters per second in the forward direction. So you generally call conventionally forward to be whatever the direction that you define to be forward as positive and backwards to be negative. Slope 2 is going to use these two data, which is basically starting from 1040 until 3540. So y2 is 40, y1 is still 40, and x2 is 35, x1 is 10. And it's going to be 0 divided by a number, so it's going to be 0, which makes sense because if you look at the graph, it basically stays at that point where the object is 40 meters away from the origin. Origin is basically where the motion has started. And then it spends 25 seconds just standing there. So this part is completely stationary, therefore it doesn't move, therefore it doesn't have any velocity speed. So number 3 is from 35 seconds to 55 seconds. Therefore, I'm going to use the y2 as 0 because it basically went back to the original position that it started this whole motion. So its y2 is 0. Its y1 is where it started this third region, which is 40. And x2 is 55. And x1 is 35 for the third region. So you have minus 40 divided by 20. Therefore, you have minus 2 meters per second again. So here, minus means your object basically had moved in the backwards direction in the region 3, which makes sense, right? Because it was at this original position, origin, where it started its motion. It went farther away by 40 meters. It just stayed there for a while and then it went back to the original position. And to be able to do that, it has to move in the backwards direction, in the opposite direction, in this third region of this motion. So you have positive velocity, which is forward, non-stationary, then backward motion. So these are basically the velocity of this object in these three different regions of this motion. So whenever you look at a graph, you really make sure that you keep in mind basically while you're working with that graph is that what graph is that? Is it distance versus time? Is it velocity versus time? Is it acceleration versus time? So that's an important point because in distance versus time graph, the slope for these three regions in our case is the velocity of those regions. So from 0 to 10 seconds, this motion has a constant velocity, which is 4 meters per second in the forward direction. It is stationary, so it doesn't have any velocity. And then it basically have 2 meters per second speed in the backwards direction. So slope in distance versus time graph gives you velocity. So therefore, because I calculated these values, the slopes for these three regions, I can draw a graph for velocity versus time for this specific motion. And I know that from 0 to 10 seconds, the velocity was positive 4. So I'm going to put a horizontal line, which means that the velocity was constant in this time interval until 10 seconds. And then from 10 to 35, the velocity was 0. So you basically make sure that it is visible from 10 to 35 seconds. It is stationary. From 35 to 55, it goes to -2. So something like this. My drawings might not be perfect, but I'm trying. 255, I said, right? Okay. So until 55. So from 35 to 55 seconds, it is going in the backwards direction, which is the negative direction. So positive y-axis basically goes upward, negative y values are going downward. So when you have negative velocity, it means you have to put it in here. So here, this is how you basically draw a velocity versus time graph from a distance versus time graph. You calculate the slopes, and these slope values are basically the velocity values of those time intervals, and you just locate them. In this case, our velocities are constant, therefore it's kind of an easily drawn. And in the next video, I will show you how to draw a graph for changing velocity. So have a good day.